Here we're asked to represent the following using summation notation. So summation notation kind of has three parts: our equation or argument here, and then our numbers that go on the top and the bottom. So I'm going to start with k. I usually like to start at k equals 0 for most situations. There are times when 0 is not the best to start with, but I always recommend to try that first. And when I look at the series here, I'm looking for what's staying the same and what's changing. So if it's staying the same, I can throw it into my argument. Each time I'm multiplying 0.5 times the square root of something. Like that's happening every single time. So that is what's going to go into my argument there. Now I notice what's changing is what's inside the square root. And how is it changing each time? It looks like every time it's going up by 0.5. If it's going up by the same amount every time, I know it has a linear type of an equation, and I'm going to have this 0.5 times k that represents that, because every time the number k goes up, it goes up by 0.5. Now, the nice part about starting at k equals 0 is that I know that whatever value begins in that square root is going to be what I'm adding to it, which will make the equation true. So then I'm going to have 0.5k plus 2 on the inside there. So that creates the argument or the equation on the inside there. The last thing I need to do is find this final number, and I could technically just like go up by 0.5 every time until I get to 12 if I was not sure what to do. But really, if I've created this equation that works, 0.5k plus 2, if I set that equal to 12, it'll tell me what the k value is. That then gives me 12. So 0.5k equals 10. Divide both sides by 0.5, and I get my final k value of 20. And again, really, if you want to ever double check your work, you can always just plug in some k values to see if they give you what's in this original series here. So plug in 0, I get 0 plus 2. I plug in 1, I get 0.5 plus 2. I plug in, and so on and so forth. And that is how I create my series.